Hello everyone. Today we are going to talk about some classic configurations of OSPF. First, if we are going to enter OSPF in the future, the first step is, of course, to create our OSPF process. This process is actually very simple. For example, when we run software on a computer, this software is an application for everyone, but in our devices, this application can be referred to as a process. For instance, in this process, we need to create the OSPF process. Here, we can enter OSPF1, followed by its router ID. Of course, if you don't set it, it will use the default global root ID on your computer. If you want to manually set it, then add the root ID at the end and assign the ID number. For example, if we want to assign it 1.1.1.1, during this process, we set its process number and our router ID like this. Can multiple OSPF processes run on the same device? It's similar to running many software applications. We can open several at the same time on a computer. The same principle applies here. So what about this router ID? It is used to manually specify the ID of our device. If no ID is specified, the device will select the largest IP address from our interfaces as the device ID. Besides this, we also need to enter the device internally to configure our area number, which means our area ID. For example, during this process, we set the area ID to area 0, and we create it using this command. The area ID here can be a decimal integer or a dotted decimal notation. If it's an integer value, its range is from 0 to 4294,9967295. Besides this, what else? In addition, we can specify the OSPF interface we are running here, which means we need to perform an action called network announcement on this interface. What does announcement mean? It means we are establishing neighbors. Announcement has two functions here. The first is to establish the neighbor relationship. If I say I want to become a neighborhood with you, I want to become your neighbor, then at this time, I need to execute an announcement. Besides this, we can also say that after establishing the neighbor, at this point, I announce the directly connected neighbor. Once the neighbor is established, if I want to tell you something, I will announce it to you. For example, if you have a friend, you definitely want to let them know if something happens, so you will tell them about it. If it's something you don't want them to know, then you definitely won't tell them. It's the same in this context. If a device wants the other party to learn this route, it will announce it to them. If I don't want the other party to learn it, then I won't announce it. Here, our network command is used to run the OSPF interface and the area where the interface is located. We refer to the network address of the interface, and there will be something following it. It's called its wildcard mask. This parameter is similar to a subnet mask for an IP address, akin to a page number in an IP address book. So when we see 255.2555.2550 in the future, the 255 is actually composed of 8 ones. And this 255 is also 8 ones. And this 255 is also 8 ones. In this process, they are all 8 ones. And here, we say that each number is composed of 8 ones. Now, when we look at these 8 ones, if you want to convert it into a wildcard mask, here you see a conversion. Completing 00 means that I am doing an exact match at this moment, whereas the previous one is not an exact match. It means that the number above is used to match you arbitrarily. In my current device, if you want to find which interface or which network segment, we do a match, which is equivalent to, after matching, I announce it into OSPF. Now, in this context, we mainly use these 3 commands. Besides this, we can also choose to modify OSPF. The cost value of an interface. Here we need to enter the interface and then set the OSPF cost. For example, cost 10 or cost 100. Both are possible. Here, the cost value is actually for our OSPF interface. I set this cost so that OSPF, under manual intervention, can choose the optimal route. Now, OSPF will automatically calculate the cost of our interface based on the interface bandwidth. So, what is the cost value? an integer between 1 and 65535. You must set an integer and not a fraction. Besides this, we can also choose to modify our bandwidth reference value when changing the bandwidth y. This means that during this process, when we calculate the cost value, it should be the bandwidth reference value, which by default is 100 divided by our actual interface bandwidth, for example, 1000. Alright, so now in this context, if it's our OSPF course above, it means you directly modify this result. Hey, it doesn't matter how you calculated it before, it's okay. I directly change it for you from the result here. Modify the bandwidth reference value. This is to change the value of 100 we mentioned earlier. In other words, here I manually set a bandwidth reference value to assign the cost of our interface. This value can be set from 1 to 2147483648, with the default being 100L. Besides this, we can also intervene. Elect Doctor, we mentioned our election process before. First, we have our priority. And besides the priority, we need to add our device's router ID. If we don't want to change the router ID here, we can set its priority. When setting its priority, we need to enter the interface and set it using OSPF-DR pretty. Here, it is used to set the priority for the interface involved in the doctor participation. So what does this value mean? The larger it is, the more superior it represents. The range of this value is from 0 to 255, and we choose within this range. Now let's take a look at an example to demonstrate this for everyone. For example, right now I have 3 routers here, namely R1, R2, and R3. Here, R1 and R3 are connected to the network, 1.1.1.1 to 32 and 3.3.3.3.32 respectively. We use loopback interfaces to simulate this. I say I have such a network segment behind. In this process, we need to use OSPF to ensure that these 2 networks are connected to each other. The configuration here is actually divided into 3 steps. First, I need to configure the interface IP addresses of the devices. Secondly, I need to configure OSPF here. Finally, we will perform a verification to check the result. Now, in this process, we can see that we need to configure the interface. For example, now here, after entering ARE, let's assume I have a network segment of 1.1.1.1.3.12 at the back. So now here I set the interface lookback 0 IP address to 1.1.1.1.12 as a placeholder address. Besides this, we also need to configure our physical interfaces. Let's configure for everyone, which means we need to enter interface 000 IP address 10.1.12.1. Besides this, on our R3, we also need to enter the interface lookback 0. Configure the IP value 3.3.3.3. Besides this, we also need to configure our physical interface 001 IP address 10.1.23.2. We will configure it as well. Additionally, although it is not written in our diagram, we actually need to configure it in essence. First, we need to enter the corresponding interface, for example, the 0000 interface. Then during this process, we configure the IP value. Suppose the IP address here is 10.1.12.2 with a 30-bit subnet mask. Then we proceed to configure interface J001. Then we enter the IP address. During this process, we input 10.1.23.1 with a 30-bit subnet mask to configure the IP value. Now, if we have finished configuring all the IP addresses, we proceed to the next step, which is configuring our OSPF. If we are configuring OSPF here first, in this process, our setting is that the OSPF process number is specifically number 1, and the router IDs for routers 1, 2, and 3 are 1.1.1.1 respectively, 2.2.2.2, 3.3.3.3, these are their router IDs. During this process, we first need to create an OSPF process, and then after the process, we create an area and enter into the area. Then we announce our interfaces. In this process, first we create the OSPF1 process, and at the same time, we assign it a router ID. In this context, if it's R2, then it's 2.2.2.2, and if it's R3, then it's 3.3.3.3. Here, we create area 0, and after area 0 is successfully created, we proceed to announce the network. First, we announce 1.1.1.13 with a 12-bit mask, which is 255.255. If during this process I want to perform an exact match for this wildcard, then at this point, I need each bit to be exactly 1.1.1.1, which is called an exact match. How can we achieve an exact match? Each bit must be 0, meaning each bit must be fixed. So now, in this process, I will look for anything called 1.1.1.1. If there is one, I will grab it and inform my neighbor, which is called an announcement, to let the other party know. In terms of network segments, if during this process I want to announce a direct connection and meet neighbors, then I need to announce that I am connecting with A1 to this network segment 10.112.0. Additionally, for example, if its mask is 30 bits, we need to convert those 30 bits in the future. When we see 255 as 8 ones, we convert it to 8 zeros, meaning we turn ones into zeros. Zeros are turned into ones, and the final conversion result is 0.0.03. In this context, we can specify the wildcard mask for declaration. Similarly, on R and R3, we also need to make a declaration. For instance, in our OSPF configuration, if we want to set up multiple areas, we need to enter the corresponding interface for declaration. For example, here, R1 has an interface in area 0 and another interface in area 1. First, we need to create an OSPF process, then set the router ID, and then in area 0, we declare 10.1.12.0, then 0.0.0.3, and in area 1, we declare network 10.1.23.00.0.0.3. We then proceed to declare each one. And on the 23, we also create the OSPF process and root ID, create the area, my site, and then declare. Here, all my 23 interfaces are in area 1. So here we declare them all at once. Network 3.3.3.3, network 10.1.23.0. But note that when declaring all interfaces, they must use a wildcard mask, not a normal mask. Next, after we finish configuring, we need to verify if there are any issues. If in the future, during this process, you need to verify, first you need to check whether my neighbor relationships have been successfully established. Router 2 can establish a neighbor relationship with Router 1 and also with Router 3. So in the future, when we use Display OSPF Peer Brief to view the neighbor summary, we will be able to see it. On the left side, it will show you the area number of the neighbor, meaning from which area you are establishing the neighbor OSPF relationship. Here, it will display the neighbor's router ID, as well as which interface I use to establish the neighbor relationship and what our relationship is. If it shows full, it indicates that the neighbor relationship has been successfully established. After successfully establishing it, we need to check whether I can learn this route. In the future, we can use Display IP Routing Table to view the entire area's routing table. Here, we are looking at R1's global routing table, and it will learn the route to 3.3.3.3 for 3.12. And surprisingly, it will send it to R2 from my own 000 interface. If during this process now, in the future when we try to access it again, I want to ping A, which means I specify the source as my 1.1.1.1 to access the other party's 3.3.3.3 to see if it works. If I receive a reply from the other party, it proves that we can communicate directly. This is an example of OSPF. If anyone wants to learn Huawei certification technology or obtain Huawei certification question banks, please send me a private message. I can also leave more comments below the video for technical exchanges.